This is the video going over the free response review for chapter 2. Okay, so again, I'm going to upload the whole rubric scoring guide they have, but this video is going to kind of help you sort through that and see what's important. So for number 1, I think it's easiest to start with what they're looking for and then go back and look at their sample solution and make sense of it that way. So I would scroll down to the 3rd page, past the solution, and go to scoring. And look at this. Oh, now I got to get it like this so I can annotate it. So look at the scoring and look to see what it takes to be essentially correct. That to them means you've done everything to get the full points. And partially correct is usually something like this, where you get some of the things they're asking for. Okay. So essentially correct, they're looking for 2 things. They're looking for, it's a histogram. They're looking that there's 6 bars and that the heights are correct. They're looking on the horizontal axis that it's labeled with numbers and words. And the vertical axis is labeled with numbers and words. And then also that the shape of the distribution is described, and there's lots of ways you can do it. You could say roughly symmetric. That would be it. Any ly word on symmetric would do it. So approximately symmetric, that kind of thing. Other things they allowed was mound shaped. Or if you said approximately normal, even that was okay. If you said normal or symmetric, it would be wrong. You need the ly word on there to soften it down. So approximately normal is good. Okay, so let's go up to their actual solutions. Here's the graph. So the things to notice, there were 6 bars that matched with, there were 6 things in the table. And both axes have the correct numbers and have words. Correct numbers and have words. So this is an easy one to miss. You kind of think, you just assume that they know it's frequency. You could also say the word counts would be fine. But maybe this is a relative frequency. Maybe this is something different. You don't know. So a histogram should have words on X and Y, and the word on Y is either frequency or relative frequency. And then the shape is what it is. It's, it's approximately normal, approximately symmetric, mound shaped, that kind of thing. Okay. Now B, what they were looking for was they wanted your actual answer for the median to be between 10 and 15. So in that bar. And then they needed some description of how you got there. Their description, okay. Let me look down here. So to be essentially correct, it has a correct value for the median and provides a reasonable justification. So they have their example of a reasonable justification. You could word it differently. It would be fine. Their example is they said, okay, if there's 91 values, okay, that's an odd number. So there is an actual number that's the median, and it would be the 46th value. And you could think, like, what if it was 90 values? Cut that in half. You'd have 45 and 45. So 91, that 46th value will be the one after that kind of initial half. So the 46th value. And so then they say they're just counting up the bars. They're showing how they count it up until they get to beyond 46. And so they know they're in the right bar. So they know it's in the 3rd bar. Okay. So again, if we go to our picture, it does mean you have to, I guess you have the numbers. You could label the numbers on and actually count up. I'm going to make you sick with all my scrolling. What are the first numbers? 8, 14, 25. So 8, 14, 25, telling you exactly how tall they are. So 8 plus 14 is 22. So this is our first 8. And now if we have 2 bars, we have 22 values covered. And then 22 plus 25 is 47. So if we go all the way to the end of our 3rd bar, we've hit our 47th value, which means that 47th value is in this interval between 10 and 15. Okay. All right. So if we go on to question 2, I want to point out something in the question before we actually go show you the answers. They said calculate and interpret the standardized score. So standardized score is a z-score, right? Don't forget the interpret. Everybody's kind of gung-ho on the calculation, but if you ignore the interpret, you're going to miss half your points. That is half of the question. You have to interpret it. Okay, so if I scroll down to, what is this, page 5 now? Well, let's look at our scoring first and then go back and look at their solution. To be essentially correct to get all your points, you need to identify the parameters to be used in the calculation. Now, parameters is a word you will learn later. Basically, it means all the things that go into the calculation. So you have to identify, basically they're saying, show your equation, show what is going into the equation, show what the equation is. They need to see the correct calculation with supporting work. So show, I know it's subtraction and division and it's easy to do in your calculator. Show it. Show what you're plugging in and then give an answer. And then a correct interpretation in context. Ooh, that's an important thing. In context. Every time you interpret something, it needs to include context. Okay, so let's go back and look at their solution. So the standardized score is, so they included their equation. They use notation, which you could do with variables. I am not really getting into that yet because there are actually different variables you use for mean in certain situations, and that's just, we're not there yet. So right now it's much easier just to use words and make this value minus mean over standard deviation. Just use that for now. It makes things so much simpler until we get to that level of complexity. And then they showed their work, they plugged in their numbers, and by showing their equation and showing the work, you are inferring here that x is 289, mu is 242. So that counts for that checks that box. And then they got a correct Z-score. And then they did not forget to finish interpreting it. So his finishing time, Clay's finishing time, there's your context. It's 1.62 standard deviations greater than the mean. And again, context, men's mean finishing time. Okay. Okay, so now on to part B. So I think the scoring part of this, I'm on page 6 of the scoring guide now, is really interesting. So it really lays out why that whole process with drawing the pictures is needed to get all of your points on a full problem. So things that they're looking for to get essentially correct: indicates use of a normal distribution. So you're telling them it's normal, and you're clearly identifying the correct parameter values, so the things that you're plugging in, the correct components, and a Z-score. So notice that they say drawing a normal curve with sufficient values marked to indicate the mean and standard deviation are sufficient methods. So that's the whole, by doing the normal curve and putting the mean and then the normal, that covers your bases. You've shown that it's normal. You've shown what your mean and standard deviation are. And you've shown, because if we get to the next, boundary and direction, uses a correct boundary value of 272 and indicates less than. That means by putting up here 272 and shading to the left, you're indicating that. You're checking that box. Okay, and then reports a correct proportion consistent. So you get a correct answer. And they're saying here with the values used in component 1 and 2, they're saying if you got dinged in the normal part, in the first paragraph here, by using the wrong numbers, but then did your calculation correctly, they would only ding you in the first part, not the second part. Okay, so if we go up to the solution here, they didn't draw pictures, they used a sentence, but pictures works great. So they said the finishing time was 272. They said what the mean was and the standard deviation. And down here, they said standard normal table. They mentioned it's normal. All those things get covered in the picture where you have, that's 259. So you're showing that it's less than, you're showing it's normal, you're showing that you know what these numbers are, 259 and 32. That picture covers all those things. Here, they showed the equation. Again, you're going to write it out in words because we're not to the notation bit yet. They showed their work so they could match up what got plugged in where, and they gave a correct answer. And then they said, using the standard normal table, that's table A, to be clear. So by saying in your work that you use table A, it is hitting that for getting to your final percentile. And by the way, the using technology, there is a way to do it on the TI-84 calculator that I will show you down the road. But for now, I really like you using table A because it's much more conceptual and takes out a whole bunch of things to remember what buttons to press and such. Okay, so then I'm going to pause and then we'll do C. Okay, part C was again very conceptual. You're finding out that the standard deviation for the women's times is greater than the men's times. So they want to know, what does that mean? And it matters how you say these things. You have to use the right words, and it matters how you say them. Don't be vague, be clear, and use the appropriate statistical words. Okay, so looking at how they graded that, they looked for two things to give you full credit. So they looked to show that a greater standard deviation represents more variability. So somehow explaining what variability means and correctly comparing the variability. So comparing women to men in this case. So for their example, they said since the standard deviation for women's times is greater than men's, they said variability. There's more variability. And then they said on average what that means. So on average, women's times are further away from the women's mean than the average distance for the men, away from the men's mean. So they mentioned the variability and they explained what that means. What does a bigger standard deviation mean? It means your data is more spread out. It means your points are farther away from the mean on average. Okay, Gerlicher out.